Assalamualaikum warahmatullahi wabarakatuh. We are from ISM KPI, Semester 2, 2021. We will present about instruction pipe learning. This is our group member. Instruction pipe learning is a technique of organizing the instruction for execution in such a way that the execution of the current instruction is overlapped by the execution it is subsequent. Instruction pipe learning improves the performance of the processor by increasing its throughput. Pipe learning processing can occur not only in the data stream but in the instruction stream as well. First is arithmetic pipe learning. This is designed to perform high-speed floating-point addition and multiplication and division. Instruction pipe learning. Here the number of instructions are pipelined and the execution of current instruction is overlapped by the execution of the subsequent instruction. This is also called instruction loop ahead. Processor pipelining. The processor are pipelined to process the same data stream. The data stream is processed by the first processor and the result is stored in the memory block. Unfunctioned and multifunction pipelining. The pipeline performing the previous function every time in unfunctional pipeline. On the other hand, the pipeline performing multiple functions at the same time is multifunction pipeline. Next is static vs dynamic pipelining. The static pipeline performs a fixed function each time. And last is curve vs vector pipelining.
Characteristic of instruction pipelining is perform more than one task at a time. It's also one method for gaining significant speedup with low hardware cost. In this technique, a task is divided into multiple steps, and each step is assigned individual processing unit. After a task has finished initial step, another task may enter that step while the original task moves on the next step. Secondly, it's similar to the use of an assembly line in a manufacturing plant. An assembly line takes advantage of the fact that a product goes through various stages of production. By laying the production process out in an assembly line, products at a various stage can be worked on simultaneously. Then new inputs are accepted at one end before previously accepted input appear as output at the other end. Next is instruction pipelining is a conceptual structure, which can be extended to various structures of interconnect processing elements, including those in which data flow from more than one source or more than one destination. Linear sequential pipelines in which all data flow through the stage in the same sequence and data remains in the same order in which it originally entered is also essentially the some sequence of steps that must be repeated many times for different data.
The performance of pipelining. It is not true that the potential increase in performance resulting from pipelining is proportional to the number of pipelining stages, because not all the instructions may have every pipeline stage that require the same time to complete, and the floating point that may involve many clock cycles. Even if no single instruction runs quicker, increased instruction throughput means that a program executes faster and has a shorter total execution time. Individual instructions are not performed faster as a result of pipelining. Rather, throughput increases. The number of stages in the pipeline architecture that will result in the optimal performance is determined by the workload parameters, which is in particular processing time and arrival rate. Example of an execution that taking more than one clock cycle, which is in I2, I3, and I4. For 2 clock cycles in this pipeline is stated to have been stalled, a hazard in any condition that cause a pipeline to stall, because the clock can only run faster than the time required for the slowest pipeline stage. An imbalance among the pipe stage affects performance. All hazards that could cause the pipeline to stall must be identified, and measures to minimize their impact must be devised.
I will continue about the advantages and disadvantages instruction pipelining. There are 3 advantages. First, the cycle time of the processor is reduced. Pipeline does not reduce the time it takes to complete instruction. Instead, it increases the number of instructions that can be processed at once and reduce the delay between complete instruction called throughput. Second, combination of several circuits. Combination of several circuits such as adders or multipliers can be made faster and by adding more circuitry. Third, pipelining increasing the overall performance of the CPU. The pipelining in theory increases performance over an up-pipeliner core by a factor of the number of the stages. Next, there are three disadvantages. First, the instruction latency is small. Instruction latency is a non-pipeline processor is slightly lower than a pipeline equivalent. Next, the designer of paperless processor is easier. The design for a paperless processor are easier and cheaper to produce by simple executing only one instruction. Third, not all instructions are independent. In a simple pipeline, completing an instruction may require 5 stages.
Thank you, Amira Nadira. In a pipeline, new inputs are accepted at one end before previously accepted inputs appear as outputs at the other end. The pipeline has two independent stages. The first stage fetches an instruction and buffers it. When the second stage is free, the first stage passes it the buffer instruction. While the second stage is executing the instruction, the first stage takes advantage of any unused memory cycles to fetch and buffer the next instructions. Next slide. The first stage of instruction pipelining is fetch instruction. It will read the next expected instruction into a buffer. The second stage is decode instruction. It will determine the opcode and the operand specifiers. Third stage is calculate operands. It will calculate the effective address of each source operand. This may involve displacement, register indirect, or other forms of address calculation. The fourth stage is fetch operands. It will fetch each operand from memory. Operands in registers need to be fetched. The fifth stage is execution instruction. It will performing the operation on the operands. And the last stage is write operand. It will store the results in memory. So that is all from us. Thank you.